Did you know that there are secrets to running FSLogix and making things better in your WVD environments? Let's take a look.
I'm Dean Safola, and this is the Azure Academy.
FSLogix is a collection of tools, and these involve 4 areas: your user profiles, office profiles, application masking, and your Java version controls. Now, we are not going to get into Java or app masking in this video. If you're interested in that, comment down below and let me know. So our 2 key areas are our profiles. Now, in the context of Windows Virtual Desktop, the Office profile really doesn't need to be involved. The Office profile was meant as a cache for disconnected or high latency connected environments. In the case of Windows Virtual Desktop, we're in the cloud, so this is not a concern. So there's your first big secret. You don't need an Office profile when it comes to Windows Virtual Desktop. So the secrets to running FSLogix and getting the most out of your virtual desktop environment are 3 key areas: performance, persistence, and protection. Now, how do we configure all of this stuff? Azure is set up in multiple regions around the world. So the big secret here is that performance is tied to your latency. So if your VMs are running in UK South, then you would not want to have your FSLogix storage in East US. And this is because of how FSLogix basically works. It's a virtual hard drive connected from a SMB file share that attaches to the virtual machine. So if the VM's over here and the storage is over there, you're going to have terrible performance. So you want these things as close together as possible. Which brings me to the 3 ways you can implement FSLogix, and that is with Azure Files, Azure NetApp Files, or a Windows file server. Now, if you're using a file server, I would be highly skeptical just because it doesn't have the scalability that something like a PaaS service does. Let's put that aside for a second, but the basic question comes down to how much performance do you really need? Everyone in VDI knows about the logon storm, so your average user, when you go through the logon process, is going to be at 50 IOPS during that logon process, and then after that, you've reached steady state, and that would take 10 IOPS per user profile. So if you have 100 users, then your steady state would be 1,000 IOPS from a single file share and 5,000 IOPS during the logon process. So which one is right for you? Well, putting this guy aside like we did a few moments ago, in FSLogix, you should have 1 FSLogix share per host pool that you have configured. Now, this is a general best practice because the host pool is a particular type of workload, and so is then the user profile, and they should be connected together so that other workloads don't interfere with them. Now, this may increase the amount of shares that you need, and management may become more of a concern, which is why you can also choose to use something like NetApp Files and have just one uber large file share, and so you don't really have to worry about it, and you connect all your different host pools to that one share. Either way, whatever works for you, and I'd be interested in hearing how you want it configured, so comment down below, let me know. But I think that there's a secret here that you're missing. So with Azure Premium Files or NetApp Files, you can scale your storage up and down in order to meet the needs of your performance when you need it. So now that you've picked your storage platform, now we need to decide how we're going to implement FSLogix because we have some options there as well. So the default way to do it is using what's called VHD locations. Now, what that means is that when you write in your user profiles, you're actually writing directly to the file share. This is completely different from how Cloud Cache works. Cloud Cache is actually going to write the data on the local C drive. It's going to create its own little hidden disk to do all of the profile writes. Once it finishes the write locally, it will replicate those writes out to the file share, and that's done asynchronously, and there's also more options there we'll get into in just a moment.
If you want to master the Azure cloud, you can start right now by clicking the subscribe button and the notification bell so you don't miss anything.
So we'll show this installation in two different ways, the manual and of course the scripted way, because everything in the cloud should be automated. So we've gone out to the FSLogix webpage, and here is the download link, which will be linked in the video description. And you just click on that, it downloads our package, and here it is on our new virtual machine that we'll be setting up in WVD. So we're going to unzip the contents and then go into the x64 folder, then go into release and then do the FSLogix app setup. And this installation could not possibly get any easier. You just check that box right there that you agree to the terms and then click install. And that's going to set up everything. Now let's take a jump over to the registry, because there's two different ways that you can configure it. So in the registry, we'll go to HKey local machine and then go to software. And under that, you'll find a folder for FSLogix. And then in there, we need to create a new key for profiles. And within profiles, there are two keys that are required as the minimum for the setup. And that is a D word for enabled equals 1 and VHD locations, which is the default configuration, pointing to your SMB file share. Now, if you feel like implementing all of your hundreds and thousands of virtual machines by going into the registry editor, more power to you. However, I think automation is always the best way. And for that, we need to look at group policy. So if we look back at the files that we've just extracted from our zip, you can see in the root here that there is an ADML and a ADMX file along with a README. And if you open that README, it will tell you where on your domain controllers you need to drop those two files so that we can use group policy in order to set up FSLogix at scale. So here's our GPMC, and I've opened it to the settings on FSLogix. So when you're going through the settings, the ones that are recommended is first to set your volume type, and that is recommended to be a VHDX file. Okay, this gives us more capabilities and it gives us more maintenance options with PowerShell down the road, because the one thing that happens if your user profile fills up all the way, just like a normal C drive, you cannot make any further writes and the disk may not even mount. And that would certainly be a terrible thing. So to also avoid that, we can set the size in megabytes that your profile should be. The default in a user profile only configuration is 30 gigabytes. Now, you might think, man, that is way too big. And if I have 100 users, 30 gigabytes, man, you know how many terabytes I'm gonna be looking, oh no. Okay, hold on, don't freak out, because there is another setting, and that is to use dynamic disks. So then when we provision our disk, no matter what the ultimate size is going to be, that disk will be very tiny in physical size, even though the logical size will look like 30 gigabytes. Another one here that's called flip-flop directory name. Now the point of this is when FSLogix by default is set up, it will have a user SID, just like this big long one, and then at the end it throws the username. And that makes it kind of hard to find what you're looking for. So this setting will flip it around, and now you've got the username first before the SID. Now this next one is recommended, but I want to give you a word of caution so you know what you're doing. Delete local profile when VHD should apply. So FSLogix is a profile management tool. If it finds on the system when John Q user goes to log in that he already has a profile on that VM, if you turn on this feature, when it finds John's profile on the system, it's going to delete it and replace it with the FSLogix profile, which may already exist out on storage. So just be aware if this is in an existing environment. If it's a brand new environment, I would definitely use that feature as well. Now, when it comes to cloud cache, there's many options for this as well, but you really don't need most of them. In fact, the only one we need to do is enable cloud cache itself and disable VHD locations. So in our group policy, if we go up to the cloud cache folder, inside there you'll find cloud cache locations. And then we need to put in a string that's going to tell it where our storage is located. So let me open this in Notepad. So our string needs to be type equals SMB, comma, connection string equals, and then the SMB share path. Now, if you want to have more than one path, which is good for DR purposes. We'll talk more about that in a minute. Just add a semicolon and add another string right after it. And that's really the only thing that you need to do, except we need to disable VHD locations. So we'll go into the profile containers folder, find VHD locations, and set that to be disabled. So the final secret to talk about in the area of persistence are exclusions. One of the big ones are the antivirus exclusions. You want to be scanning them for sure, but you want to do that separately. You don't want to do it when it's being mounted to a local system, because that's going to cause the local system's antivirus, CPU, etc. to have to kick up and do all the scanning. We can do that through a bunch of settings here that can be excluded through your antivirus software. And if you're using Windows Defender, this can also be implemented through group policy. And now the third secret section, talking about the protection of your FSLogix profiles. Protection comes down to three basic areas, and this is backup, HA, and DR. In Azure Files, this is pretty easy. We can integrate it with Azure Backup directly and then protect that file share, and we've covered that in a previous video, linked right over there. In NetApp files, it's a little bit different. There isn't an inherent backup feature to NetApp files. However, there is a new feature on NetApp replication where you can replicate your data from one NetApp appliance to another. And if you're interested in a video on this, comment down below, let me know, and I'd be happy to create that. Which is a great segue into high availability and disaster recovery. On the high availability front, one of the things you can configure in FSLogix, either VHD or Cloud Cache, is the ability to have multiple file shares. I've got my session host over here, and I've got my user profile disk. In the VHD scenario, I'm going to mount that disk from the file share over to a particular session host. The FSLogix agent on that system is going to do all of the writes out to the file share. I can set up a secondary share. The writes would happen over here, and other writes would happen over there. And this can function kind of like an HA setup. If I happen to lose my Azure file share, the NetApp share is still working with all the data. The way Cloud Cache is implemented, the writes on the session host happen locally on that hidden profile disk and then replicated to Azure files. And I can set up another write to go to NetApp files. Particularly in Cloud Cache, this can function like a disaster recovery mechanism because the writes happen locally on the session host. In VHD locations, the writes happen in Azure File Storage. So what if I lose Azure File Storage? Then I can't write to my profiles and we're going to have problems. In Cloud Cache, it doesn't matter if you lose connectivity to Azure File Storage because the writes are local. When connectivity is restored, the writes will be replicated. So this sounds awesome, right? Why would I even bother with VHD locations? Well, there's one little caveat, and that is that Cloud Cache, being more robust as it is, also takes longer for each user to log on. Add approximately another 4 seconds for Cloud Cache in this type of configuration, because no matter how much we try, we still can't change the laws of physics. Here's our bonus secret if you have reached those kind of problem situations where your profile disks are running out of space. The secret here is that your FSLogix profiles scale up, but it will never scale down. So if you had a VHD that got mounted to a system and you happen to load up several video files, and that took up, let's say, 10 gigs on that local profile. The disk is now expanded by those 10 gigabytes, and you need to take a manual intervention in order to make it shrink. This link out to GitHub is in the video description below. You can run this against your profile share, and then it will mount each disk, clear out all of that white space, shrink all the disks as much as possible, and then unmount them, leaving them in the file share for use. You definitely want to do this during some kind of maintenance cycle when your users are offline. So what exactly is an Office profile, and how is it different than our user profiles? Well, a user profile has important data in it. This could be documents, this could be configurations. It's persistent data that we need to travel with us from machine to machine as we're moving around our WVD environment. The Office profile, on the other hand, is a cache, which means that it's only a local copy of real data that exists somewhere else. However, it can still come in handy for performance optimization or controlling the size of your user profiles. So since the Office profile is a cache, what are we caching? Well, this is completely configurable by you, but it can include things like OneDrive, OneNote, Outlook, SharePoint, Skype, and Teams. And it can all be configured through your group policies or your setup scripts, which we'll talk more about in a minute. So if you're going to use both of these profiles for a single user, the question is, where should you store it? You see, we have two different kinds of data, largely persistent data in our user profile and cache data, which is going to have a lot of reads, writes, adds, and deletes in our Office profile. So the amount of IOPS required for Office may be quite a bit higher than for your user profile. Just think about it. How many times do you change your background wallpaper? Or do you create a new Word file on your desktop or in your My Documents folder? Even if you do that a whole lot, you're not doing it near as much as OneDrive would be syncing, let's say, a whole folder onto your computer, or Outlook caching 6 months worth of email. So part of the answer to this question is also going to be, how many users are you supporting? How much storage does it take up? And how many file shares do you have? Again, keeping in mind the best practice principle of one file share to one host pool. And that can get into an area of concurrent connections. More about that in a minute. Now, like we covered in our last video on FSLogix, our user profiles need to have a backup, HA, and DR. But some good news here, in your Office profiles, you don't need any of that stuff. Now, the reason why this is the case is because this is cache data. The real info lives up in the cloud somewhere else in one of the Office servers. You just have a local copy. So if the worst thing happens and your Office profile is completely wiped out, no big deal. You're just going to recache that stuff from the Office server, which you're sitting right next to anyway. So we don't need to back it up. But depending on how you configure things and your particular requirements for HA or DR, you may want to have those file shares aligned with how you're doing your user profiles, just to make management a little bit easier. The first question that we need to ask is, in which host pool scenario should you use it? The pooled host pool is where we have multiple desktop instances, but this is where Windows 10 multi-session comes in. And that's your typical hero solution for people just getting started with WVD. The next kind would be the remote application host pools. Now, this is kind of like a pooled pool in that it is Windows 10 multi-session, but you don't get the full desktop experience. This is remote application only. So you may or may not actually need an Office profile or a profile at all. And that really comes down to the applications that you're hosting. More about that in a minute. Then we have the personal host pool. Now, a personal host pool is where you have one user to one virtual machine. That's their personal computer. Just as if you would have given them their own laptop, now they just get their own instance of WVD. But specifically thinking about FSLogix and personal desktops, this really isn't the situation that I normally recommend using it, because that is that person's only computer. The point of FSLogix is that my profile can be on any computer, and so all my data and configuration settings all go with me no matter where it is I end up. In personal, that's the only desktop I'm going to be using, so not really a place for FSLogix. But what if you're using a personal host pool and remote applications? Now things start to get a little tricky. There are two kinds of applications, those with configurations and personalizations, and those without them. So if you're using a web browser like Microsoft Edge, this could be just used as a installed default web browser. What you see is what you get. That's it. No profile necessary. You can even configure it with something like group policy to have those configurations centrally managed and controlled how you want it to be. Again, no profile necessary, because everything is handled centrally. This is different than when you open an application like VS Code. You can certainly run it without a profile and take all the defaults, but when you want to add any customizations for yourself, those get stored inside a configuration file located at that path. That means each person needs their own settings.json file, and hence everyone needs their own profile. But going down the rabbit hole a little more, sometimes you end up with concurrent connections.
If you want to master the Azure cloud, you can start right now by clicking the subscribe button and the notification bell so you don't miss anything.
Now there's a lot to go over here in concurrent connection, so stick with me, because the problem in any of these concurrent configuration settings is that your users may not understand what it is that's going on and may have different expectations than the experience that they're actually being given. There are three basic types of connection that you can make with FSLogix to your profiles, whether that's user or office. The first one is a single connection. One VHD for your profile to one session host. That's the default behavior and the one, quite honestly, that's most easily managed. The second kind of connection is where you have multiple connections to the VHD from one Windows machine. And the third type is where I have my VHD mounted to two different session hosts at the same time. Now, the way that we get all this magic to happen is through what's called a differencing disk. And to understand that, let me explain the modes of connections. The first mode is mode 0. Basically, no differencing disk is involved because you're in that default connection state of one VM to one session connection. And that's the one I most generally recommend, especially if you're new to FSLogix and WVD. But from here on, there be dragons. In mode 1, we take your VHD or VHDX file, whichever one you're using, should be VHDX, and you're connecting that to your session host. We will also create in storage in the same location an rw.vhdx file, and that is your read-write differencing disk. Because when we mount that VHD or VHDX to our session host, the disk is locked, meaning that the session between the VM and the disk can only be written to from that one place, that one location with that one ID. The differencing disk of read-write gives us the option to write to the original profile and write to the read-write differencing disk. So you can have two different connections to the same VHD from the same session host. The next mode is very similar, and that's mode 2. Instead of a read-write version of that differencing disk, you get a read-only version. This could be good in that VS Code scenario where I don't need to necessarily make changes to my settings.json file, but I do need to be able to read it so I get the experience I want. And the grandpappy of them all is mode 3. This is where we have a read-write configuration, but will fall back on a read-only configuration. And the way that that works is a check will be made. Does the rw.vhdx file exist? If not, then take on the read-write role. But if it does, take on the read-only role. Now, our office profiles are configured exactly as our user profiles are, and that's using the Group Policy Management console. So I'm protecting here several different applications like Outlook, Teams, OneNote, and SharePoint, but whatever works for you. Now, when you set up the Office container and have a user log in, you're going to get two different virtual hard drives mounted to the system. As you can see here in our disk configuration manager, you can set the size in megabytes for your virtual hard drive, just like you could in the user profile. I would make this disk over provisioned in size while being dynamic. That way you have less need of doing actual maintenance on the virtual hard drive. Now, when your user is logged in, if you go to See Users, then you will see all of your user profile folders, and a FSLogix user will have two of them. You can see here we have Black Widow and local_Black Widow. What's the difference? The Black Widow folder would relate to your user profile data. That's your typical stuff like your desktop documents, pictures, app data, etc. The local_Black Widow file has to do with all of that stuff that is not really in your profile, but it has to be present on the local system when you're logged in. And this also comes in with exclusions and redirections. More about that in a minute. Now, if I flip over to my FSLogix Share, where my virtual hard drives actually exist, and I go into the Black Widow folder, you can see I've got an ODFC for my Office container, a user profile, and then I also have a lock file and a metadata file. The lock is there, as I mentioned earlier, because I'm logged in and can only be written to within my particular session. So let's go back to GPMC for a minute, and you'll see the third one that I have enabled is to provide a redirect XML file to customize redirections. This is where I can take things that would generally be allowed and say, I don't want them to be in there, redirect them to that local underscore file so that I don't actually keep them in my profile taking up space. And I'll show you how to implement this with Teams, which is another big example. Teams takes up generally about 5 gigabytes worth of cache data that you really just don't need in your profile. So I'll show you that in a moment. So back in the profile containers folder, I'm going to enable concurrency. To do that, we have to turn on the feature of profile type, and then we can set that to whichever level of concurrency we want. I'm going to set it here for mode 3, which is read write and read only. And then I'll go to the Office 365 container, and I want to set the same thing here called VHD access type. So let me log off my Black Widow user and then log back in, and I'll go back into my FSLogix share, and now things look a whole lot different. Starting at the top, I've got my equivalent of my read-write disk for my Office profile, then the Office profile itself, my user profile, and then the associated lock and metadata file, and then the read-write file with its lock and metadata. One final word on concurrency, and that is over here in the FSLogix documentation. You can see a very clear warning that OneDrive is not supported in any kind of concurrent configuration at all under any circumstances. Now you can still do concurrent connections by using exclusions. And since the more common use case for doing exclusions is Teams, let me show you that real quick. So here's my FSLogix share, and in the share at the bottom, you can see that I've got a redirections.xml file. So the important line here is the exclude block, and we have listed the cache folder for Teams, which means we won't be putting that in our profile, but instead we'll put that in the local underscore folder. You just need this file to be present here, and back in our group policy in that redirect XML customization location, you just put in the path to the file share, not the file itself, just the file share. Just save it, update your group policies across your machines, and that will exclude Teams cache data from your profile, saving you about 5 gigabytes per user. And just like when you're planning for your applications, we need to start with the requirements for FSLogix. The first one is simple, and that's capacity. How much storage do you need for your profiles? And you know as well as I do that profiles will only grow over time, so we need to think about that as well. Now, if you have an existing VDI environment of some kind, then you need to look at your average user for how large their profile is as a good place to start. If you don't have an existing environment yet, then you just really need to take a guess. And don't worry, that's not near as bad as it sounds, which I'll explain in just a minute. Or you can just set up a quick test environment, have users log in, set up everything the way that you think you want it, and then just take the average. In my environment, after I've already set up everything and people have been well using it, I end up with about 4 gigabytes as my average profile size. So some simple math says that I have 4 gigabytes per user on average, and I've got 4,000 users. Now that means I need 4 times 1,000 or 4 terabytes worth of disk space in my storage for my profiles. But wait, there's more. Each profile will be stored as a virtual hard drive file. And there are 2 best practices that you should remember. The first is that you can choose to store your profiles as VHDX files. And when you do, that lets you use the second best practice, and that is dynamic disks. And implementing both of these will help you to manage your growth of your profiles over time. It lets Windows think that there's as much space as Windows thinks it needs, and then your actual size on disk is going to be smaller, but it will be allowed to grow, which means you don't have to babysit it. And remember, this is the average user. You will, of course, have users who use far less and some who use far more. And as far as those big ones go, it's really not as bad as it sounds, because now you just need to do maintenance on 2 or 3 users rather than the entire fleet. Now, I did say earlier that it was okay to guess on your profile size if you don't have an existing environment or test environment, and that's really okay because we are in the cloud. And honestly, even if you had an example user, you probably aren't going to be 100% accurate, and there are a few reasons why. And the first we already mentioned, profiles grow over time. It's going to change anyway, and you're going to have to adjust for that. The second is, it's the cloud. You can always increase or decrease the size of your file share with the click of a button, so it's not really a big deal. And changing the size of that share will also increase or decrease your cost as well, so keep that in mind. And there's one other thing to think about, and that is the management of your profile storage. And what I want you to think about here is how we can separate our FSLogix profiles into different kinds of workloads. So the best practice here is to align your profile share with your host pools. Now, this is just like what we talked about in episode 3. Your host pools are a collection of identical virtual machines that are all doing the same job. And that means that your user profiles are also based on a specific type of workload and configuration, so it makes sense to have one share for one host pool. Now, there are some other things in your FSLogix configurations that may make you want to have more than one share per host pool, and we're going to deal with that in our next episode when we plan on our user profiles configurations in FSLogix. So be sure that you've rung the notification bell so you don't miss that. Now let's talk about the other side of our requirements, and that is performance. We want our users to have as great an experience as we can provide without breaking the bank and spinning up bigger and faster storage than what they can really use. And since I don't know exactly what you and your users are going to be doing in your environment, let's use some good, solid, average numbers to tell us the kind of performance that we need. When you have a user log on, their profile gets mounted onto the virtual machine, and then that will consume 50 IOPS per user. And then after everything settles down in the logon process, they will average around 10 IOPS per user. Now, so IOPS stands for input-output operations per second. It's a good common way to measure storage performance. And of course, there is more to performance than just raw IOPS, and you can certainly go down that path if you need to. But for today, let's just use that as a good standard. And we know how much capacity we need. We know how much performance we need. The question now is, where should we put our profiles? Now, there are several links in the video description below in the resources section as usual, and this first link goes over to the WVD docs showing this table with the 3 supported storage platforms for FSLogix and WVD. And that is Azure Files, Azure NetApp Files, and a Windows Server with Storage Spaces Direct, and each one of them does have their own benefits. The one thing to keep in mind no matter which storage solution you pick is that location matters. Just like we talked about in episode 5 about our network planning, you should keep your FSLogix storage as close to your session host as possible, which will keep latency as low as possible. And in Azure speak, that means the particular region. So if your host pools and your VMs are in the East US region, your storage should be there too. So which one of these storage platforms is right for you? Well, let's understand a few things about them. Storage Spaces Direct is a self-managed storage solution built on top of a Windows file server cluster, and it needs a minimum of 2 Azure virtual machines. They will also need to have multiple high-performance disks, and you will need Azure Blob Storage as a cloud witness. Now, managing your own server for this kind of thing means that you will have more control over the VM size, disk configuration, the cost, the security. However, it's not as scalable as the other solutions, and troubleshooting is all on you. So if you've never managed a Storage Spaces Direct cluster before, I would not suggest that you start now, especially because you can get much more scale with less management out of the other cloud platform services. So let's talk about Azure NetApp Files. Now, I know that there are some customers that approach the cloud with the one throat to choke philosophy, which basically means that you want to only deal with one vendor so that if you have any problems, you know exactly who to go to. And with that in mind, some of you may not even consider using Azure NetApp Files because you think that it's, well, NetApp, so it's another company, and I don't want to deal with that. So let me set the record straight. Azure NetApp Files is a true first-party service in Azure, just like Azure Files or Windows Virtual Desktop. It is NetApp storage technology that is operated and supported by internal Microsoft personnel who are NetApp experts. This is not a NetApp direct offering or solution. This is all 100% Azure. Now, with that out of the way, Azure NetApp Files is the highest performing solution in the cloud today for your storage. You can have 12.5 petabytes of storage with speeds up to 400,000 IOPS out of a single appliance. Now, with all that performance does come cost, so let's break this down a little more. There are 3 tiers of NetApp performance that you can get. Each one has their own layer of cost and performance, but something to keep in mind, if you are using Azure NetApp Files only for WVD and you have less than 6,000 or 7,000 users, you probably want to think twice. And that's because the price per user versus the cost of the solution. However, if you have other file services workloads, either SMB or NFS, especially any other enterprise class file workloads, then that along with WVD could be a great choice for you. You could put all of those multiple solutions under a single storage platform, which of course means easier management. But life is full of trade-offs, and there's some things you need to know to balance out your decision. And the first is backups. Now, NetApp today supports taking snapshots inside the appliance. And that does mean that if something somehow went wrong with your NetApp instance, then you might not only lose your data, but you may lose your backup data as well. So you can protect your data in another way in NetApp, and you could do that with a feature called cross-region replication. This would require 2 NetApp instances in 2 different Azure regions, and it protects the data by replicating your volumes from the one to the other. And not only can this function as a backup solution, but it's also a great DR solution. Another thing to consider are the number of connections. A single NetApp appliance can support up to 1,000 virtual machines connecting to it today. So you need to consider how many total hosts that you have that are communicating with this NetApp appliance. And that's across all of your workloads put together. So if you do the math, are you over 1,000 VMs? If so, you need more than one NetApp instance. So the last thing to think about in your Azure NetApp Files is performance. The maximum IOPS of one NetApp instance can be 400,000 IOPS. And remember, if you have your FSLogix shares divided by host pools, which is a best practice, and you have 3 host pools, you need 3 shares. So the 400,000 IOPS refers to the collective performance across all the shares on that one appliance. If you need more than 400,000 IOPS, you need another NetApp instance. So the third solution here, of course, is Azure Files. Now, Azure Files is built on top of Azure storage accounts, and there are 2 performance tiers, Standard and Premium, both of which can support up to 100 terabytes of data per share. Now, the standard shares by default can have 1,000 IOPS per share, but there's a flag that you can flip that's called large file shares, which will make standard go up to 10,000 IOPS. Premium can go up to 100,000 IOPS. Premium also has a benefit that's called SMB multi-channel, where you can increase the number of network connections from your VMs to the share, and you can get more performance that way. As for backups, we've got a few options. You can take snapshots right inside the storage account, kind of like with NetApp, but you also have the option of using Azure Backup, which not only will manage those shares for backups and restores, but the data is also stored in an Azure Backup Vault, which is separate storage than the storage account. So if the storage account is lost for some reason, the data is still in backup and can be recovered. So here's our scenario for today. We've got 5,000 users we need to support in Windows Virtual Desktop, and that's broken down into 3 different kinds of users that are spread across 3 regions. Now, the best practice for FSLogix is to have 1 file share per host pool. And since we have 3 different regions with 3 different kinds of users, and we'll have 3 different host pools, but we need 2 file shares for FSLogix. We also need to make sure that 1/3 of our users can be online at the same time from each of the individual regions, because we have a follow the sun model. And on the security authentication side of things, we are going to be using Azure Private Link to isolate our WVD session host within a region to their own file share so that nobody else can access it. And the authentication piece is going to be handled by Active Directory integration with our Azure Files account, followed by setting up all the Azure Files permissions on that share and the NTFS Windows permissions for least privilege access. And that also means that we're going to have to update our network security groups and our spokes to be able to communicate with Private Link. So now that you know what's going on today, let's go build us some storage accounts. Now we're going to need users to access our storage account. So I'm just running Azure AD Connect with the Express settings. And this is not normally recommended in a production environment, but since this is just our lab for the AZ140 test, Express is good enough because it'll just sync everything across into Azure. And over here in the Azure portal, in the users section, you can see there are all of our users. So Azure AD Connect is working, but we also have groups. And they're all called WVD_users_ whatever the region is. And that's so we can have our storage account by private link to the subnet where the host pools are located, isolated to just those user profiles. Okay, so let's just go click on the plus in the top, and you can scroll down to the bottom and select storage accounts. We want to choose the WVD resource group first in the East US. Then we have our name for the storage account. Now, names in storage accounts can be a little tricky because you can't use any special characters. It's only letters and numbers. And then the next thing to think about is the length of the name. So you can have 24 characters in a storage account normally. However, because we are doing the Active Directory authentication integration for our storage accounts, your name needs to be 15 characters or less, because that's a standard Active Directory NetBIOS limitation. So I'm going to call mine STOR and then put in the region, EUS, and then have something at the end. It could be your alias or the first part of your email address or just anything you want. I'm using AZ140. Now, one more thing about storage account names. They need to be globally unique. That means when I create this storage account, your storage account cannot have the same name. Now, we still want to follow the same naming convention here so we're all on the same page. So at the end of your storage account, don't use AZ140, use something else. And just be sure, again, that you stay under that 15 character limit. Then we have the particular region selected, East US in this case. And then we have our performance options, and this is either standard or premium. And we also know from our scenario that we need 1/3 of our users to be online at the same time. So 1/3 of 2,000 users is about 660 users, and that number times 50 is 33,000. Now with standard, the maximum performance you can get out of a single file share is 10,000 IOPS. So we need to go with premium. When you choose premium, you have your account kind, and you need to select that as file storage. Then for your replication options, you have 2 choices, locally redundant and zone redundant. In this case, local redundancy is just fine because we're going to be using Cloud Cache to replicate our storage between our different regions. So let's hit next for our networks. Here in the networking section, you can see we've got 3 different options up top. And by default, all storage accounts are accessible from the internet, and that's what's included with all networks. Now that doesn't mean that your data is out there and exposed to the internet. We still have things like SAS tokens to secure our storage accounts, but it has to do with where the endpoint is that the clients communicate with. When it's set for public endpoint, that means that there is an IP address out there on the public internet that your storage account will respond to. If you choose the middle option, that would be public endpoints from inside selected networks where you want to isolate it to on-prem or to Azure Virtual Networks. But that's not good enough in this case, because we don't want just any old VNet to be able to access our storage. We want only one specific subnet to be able to get there. So we need the private endpoint. And when we do that, we've got a new section here that we've got to fill out. So over there on the left, click Add, and then you get this blade here that we need to fill out, starting with their subscription and resource group. This should be, of course, for our WVD spoke in the East US location, and then our name. I'm going to use PRIV and then put in the abbreviation for the region EUS, and then end it with AZ140, just so I know that it's related to this storage account. The storage subsystem in this case, your only option is file, because this is a premium account. And then we have our network. Now for the network, we want this to be our spoke WVD network, since we want that to be isolated to our session hosts in the EUS. Then we have the private DNS configuration at the bottom. This is going to help your systems be able to locate the storage account, and we definitely want to use that in our solution. So go ahead and hit OK at the bottom. So let's hit Next for data protection. Now the only thing here that relates to Azure File Storage is soft delete. All the rest of these things here are for blob storage. Now soft delete is enabled by default on your file shares, and I'll show you how you can disable it if you want to, since this is just our lab. But if you wanted to enable it, you just check the box and then tell it how many days you want to retain data after you've deleted it. And of course, soft delete is so that you can recover it without having to go to your Azure backups. We don't need to make any changes here on the advanced screen, so hit Next and add your tags. And these are just the standard tags I've used throughout this series, and that would be the application, the environment, the owner, and most importantly, the cost center. And when you're ready, go ahead and create. Now I'm not going to walk you through provisioning the other two storage accounts. It's the same process, just with different names. So pause the video if you need to, go ahead and get that done. And then when you're ready, I'll meet you in your storage account. Okay, so my stuff is finished. There's my 3 storage accounts, each one in their appropriate region. So let's click on East US, and you can see the only service that's available here is file storage. That's because it's a premium files account. Now over on the left, you can click on networking, and at the top you'll see it's selected networks has been chosen, but there are no networks actually picked. But switch over to the private endpoints configuration tab, and that's where you'll find your private link instance, and it is set to auto approve. Now go ahead and click right over here where it has the private endpoint, and that'll take us over here to the private link blade. Starting at the top, we've got our virtual network, which shows our WVD spoke, and then we have a network interface. So the way private link works is you actually get a Azure network card, and that card has an IP address that represents the service, Azure Files in this case, inside your virtual network. That's how we're gonna write our NSG rules in a few minutes. Then over on the left, we have the DNS configuration. And this is that Azure private DNS zone that we set up in the process. And that shows that we've got a fully qualified domain name for our Azure Files representation, as well as a private IP address. And one last thing, if you go to the search at the top, we want to do a lookup, private DNS zones, and just click that, then you should have at least one instance of an Azure private zone, and that should be located in our network resource group. And here you can see all of our private DNS records for the East US, Japan, and UK. And then what makes the magic happen is over there on the left, the virtual network link. And this is where that private DNS zone gets registered with the individual Azure virtual networks in our hub and our spokes. So this way we'll be able to use one private DNS account for all of this information. Now remember, I told you before that soft delete is enabled by default, and up here in the middle you can change that. And when you click on it, you'll get this blade here, and you can just disable by flipping the toggle right there and then just hit save at the bottom. So the next thing to do is create a file share. So go ahead and hit the plus file share at the top. And when you do, you'll get this blade here at the side. Give your file share a name. To keep them all consistent, I'll use share, then the region of EUS, and then AZ140, so I know that it's related to this same storage account. And then we have the size of the share. Now, size in premium is directly tied to performance. So I've chosen a 10 terabyte share. So the baseline IO when we do 10 terabytes is around 10,000. And that's great because that's my steady state number. But when I have all those login, log offs, I'll be using this burstable number that goes up to 30,000. So I should be fine. When you've got that set up, hit create at the bottom. Now, just one more thing to keep in mind is that premium storage accounts bill based on on the size of the file share. So the clock is now ticking. Now, because these file shares can be dynamic, what you may want to do is adjust the size of the share smaller so that you would be billed less until you're ready to start ramping things up with all of your users. And you can do that just by clicking the three dots over here and then clicking Change Size and Performance. And the smallest size that we can create here is 100 gigabytes. And so that's what I'll set mine to because I'm going through this as a video process for all of you. So that way I don't burn all of my Azure credits. And then just hit update at the bottom. And our size has been updated. Just be sure that you put it back to the right size before you start onboarding your users. Now that we have a share, we need to get authentication going. So go ahead and click the link over there where it says Active Directory Not Configured. Now at the bottom of that screen, you'll see identity-based access for file shares, and it calls out Azure Active Directory Domain Services, and there's just a button to go ahead and easily enable that. Do not click that button. We're not using Azure AD Domain Services in this case, we're using a regular domain controller. So what you need is the link at the very bottom, how to domain join this storage account. And that'll open up a link over here on the side that's actually the Azure doc. And you can click the link up here at the top, and that'll just expand it out into a new window and make it a little more readable. And what you'll want to do is click on this link for part 1, and you're going to scroll down just a little bit to this Download AZ Files Hybrid module. Now we're going to access our domain controllers over Azure Bastion, so go ahead and copy that link. Then back in the Azure portal, go find your domain controller that's in East US, and then hit the Connect button at the top. From there, you'll want to click on Bastion, and then click on the Use Bastion button. And because we're logging on to a domain controller, provide the appropriate credentials, and then hit Connect. Now when you do, a new tab will open, you'll be logged on, and pick up right where you left off. Once again, browsing the internet from a domain controller is not a best practice, but because this is our lab and we don't have an administrative server, we're doing it from here. But anyway, go ahead and click the link right over there and download the zip file. And once that's finished, go ahead and extract all the contents. And then you want to copy the path where all of these files are and go into PowerShell. And to make things easy for yourself, go ahead and switch directories to wherever that was. And you should see that you've got 3 files in there. Then flip back to the Azure Docs and scroll down just a bit until you find this very large PowerShell block, and then copy all of that code. And just paste that back here into PowerShell, and we've just got a couple quick edits to make. So I've added my subscription ID, resource group name, and the name of the storage account. And we'll just scroll down a little bit. You can see that we're referencing those as variables, and then we have this domain account type. And I've chosen to use a computer account here instead of a service account. The next line is optional, and this is for specifying an OU to create the computer object in. And same thing with encryption type. This is optional as well. This determines how Kerberos auth is done. I'll leave those up to you. I'm actually going to delete both of them because in this lab it doesn't matter. So go ahead and highlight lines 1 through 30 and then just execute that code. And when you do, you'll see this warning that we are changing the execution policy in order to run this particular script. That's okay to do because 1, this is our lab, and 2, after this PowerShell session closes, the policy will go back to normal. So go ahead and hit yes to all, and then the files will be copied to the appropriate places and you'll be asked to sign in to Azure. And after that, it'll run the script to join your storage account, which will just take a moment. So that looks like a good output. So if you go back to the Azure storage account, and then in the configuration section of the blade at the bottom, we've now got 2 different identity-based options. Azure AD Domain Services, which is now grayed out, and then under that, Active Directory Domain Services, which is now enabled, showing which domain we are joined to. And just to verify everything, go to the file share, and at the top it now says Active Directory is configured. So it all looks good. Now we need to assign the permissions. And there's 2 layers to this, Azure Files and Windows NTFS. Now because of how Azure AD Connect functions, your domain admin account that you're logged in with will not sync over to Azure. That's just a security feature in Azure AD Connect. So to get around this for our storage account permissions, we're going to take Adam Warlock and give him the rights of domain admin, and then we can finish the rest of this back in the Azure file share. Go over there to Access Control, then at the top we want to click the Add button, and then select Add Role Assignment. When you do, you'll get this pop out here, and you want to choose your role at the top, and scroll all the way down until we find the storage file data SMB share elevated contributor. Then you'll need to select your user that you want to have those elevated contributor rights. Now in this case, I'm going to choose Adam Warlock, then go ahead and add another role assignment. This time we want the share contributor. And because this is the East US, go ahead and search for that WVD users USA group. And when you're done, you should have 2 different permissions assigned. Now it's the elevated contributor that will have the rights to set the NTFS permissions, but in order to do that, we have to map our drive first. So at the bottom on the left, let's go back to our file share. Then you want to click those 3 dots again, and this time select Connect. And if all goes well, the authentication method should be Active Directory, and you'll have a box of code right here. Go ahead and copy that, and then we want to go back to our domain controller in the Azure portal, and then in the Bastion Connect settings, go ahead and log in with Adam Warlock. And just open your PowerShell ISE again and paste in your code, and then go ahead and run it. And that'll just take a quick second to run, and you should have a new Z drive map. So right click on that and go to Properties, and then go to the Security tab and click Edit. Now you should see that Adam Warlock is already here and he's got special permissions. That's what that elevated contributor role did for us. But now go ahead and click Add. And when you do, you'll be able to search for the right thing that you need. In this case, we're looking for WVD users groups, and you want the one for USA. And when you've added that, just hit OK, and you'll get this warning about setting permissions, and yes, we want to continue. Now that you've added the group, click on Advanced, and you want to set the creator owner rights to have access of Modify, applying to subfolders and files only. Adam Warlock is our administrator, so he should have full control over this file, subfolders, and files. And finally, the WVD users USA group should have Modify access on this folder only. And that sets up the least privilege access rights according to the FSLogix docs, which are linked in the description below. And the last piece of the puzzle are our network security groups in the spokes. So we've created here rule 180, and that's to allow SMB outbound, and that's on port 445 on the TCP protocol from the virtual network, which would be the spoke, to a specific IP address, and that's the one of our private link, 10.1.0.4 for the East US. Now I've got some homework for you, so don't run away on me just yet. We need to set up the other 2 storage accounts in Japan and UK, and we need to create the file shares and private link and all of that stuff. Keep in mind though that in Japan we will not be using FSLogix, but we will be using MSIX AppAttach, so be sure to create that in Japan, UK, and in US, and repeat all of these processes. So you go and complete that homework so you're ready for the next episode. Speaking of which, we'll next be getting into making our images for our session host so that we're ready to deploy our host pools. And all this stuff is in the AZ-140 study guide series right here at the bottom, and you can always catch the latest Azure Academy video at the top. Thanks for joining me today, and I will catch you in our next episode. Happy learning.